right, so good morning, good afternoon, everybody. Thank you for your patience, live and YouTube audience. We had some tech difficulties, and that's half the fun of broadcasting the first full week of the year. Something has to go wrong, otherwise we're not having any fun. My name is Jesse. For many of you, it's your first time joining us. If you're coming back, welcome back. We have almost 1,000 kids registered today for this epic program. I am so excited to have you all here for one of my very favorite speakers we ever have on here at Exploring by the Seat of Your Pants, who I'll introduce in just a minute. Now, if you are new to us, we are all about bringing conservation, adventure, and science into classrooms around the world. Everything we do is on our website. We've got 18 programs this week, 35 plus this month alone. It is an incredible journey, and a big thank you to you for continuing to join us as we get to showcase and celebrate the coolest explorers and scientists on planet Earth. Everything we do is on our YouTube channel. Check it out. Subscribe. We've got our daily dives. We've got a lot on the go. It's a really exciting time to be interested in science and exploration. Now, before we dive in with today's program, I will note we are going to have a little Kahoot together. Class's favorite thing. So after the talk, before the Q&A, 4 quick questions, test your understanding, have a little bit of fun. You can bring that up in a separate toolbar at the top of the screen, and we will get to that right after George's talk. Now, without further ado, George Kourounis is joining us. He is the world's coolest living explorer. He has been all over the world, every continent, many times, epic ships into the doorway to hell in Turkmenistan. He's been in wicked cool caves in Mexico. Everything he's done's on our YouTube channel at this point, but we've had him on like 40 times. But today, we are getting back to George's roots to talk about the world's weirdest volcanoes. He's been to all the world's volcanoes. We'll talk about that in just a second. You know what? I'll bring him in. George, have you been to all the world's volcanoes, or do you have a few left to tick off at this point?
Oh, not even close, Jesse. Not even close. There's about 1,500 active volcanoes in the world.
Oh, I thought you were at 1,450 at this point. I mean, every time you talk to you, you're somewhere new. George's website and his social media presence, you've never seen more epic imagery or videos in your life. Check it out. But today, as he said, we're going to dive with volcanoes, and I'm excited. I'm going to let you take us away.
Thanks so much, Jesse. I appreciate it. I apologize for the technical difficulties. So we're going to smash right into this. Today, we're going to be talking about the world's weirdest volcanoes. Not just regular I got to share my screen. That's important now, isn't it?
It's one of the important.
Holy cow, I'm getting ahead of myself.
That's a good problem to have. I think us being as enthusiastic as we are is like the best part of this thing.
Exactly.
Yeah.
Whoops. Oh, geez. There we go.
Wants to work. It's thinking about it. Smack it.
There we go.
Perfect. It's in. It's good. You're golden. I'm disappearing.
So, I'm pretty sure that everybody out there knows what a volcano is. So I'm not going to go into like super detail about normal volcanoes, other than to say that, because we're going to talk about the weird ones today. That's specifically what we're talking about. I love weird natural phenomena. That's sort of my specialty. So when we think of volcanoes, we typically think of like rivers of lava flowing from an eruption somewhere. And this is a photograph I took from a helicopter in Hawaii over Kilauea volcano. So it's got that very typical situation where the magma from deep inside the earth comes up through a volcanic vent. It now becomes lava and flows over the landscape. That's very normal. We also have some volcanoes that have big explosions because the chemistry of the lava is stickier and the pressure builds up. And instead of oozing out over the landscape, the pressure builds up and it'll explode with these huge eruptions. And this is from Semeru volcano in Indonesia. And it took me 2 days to climb this volcano to take this picture. Extremely cool. But that's also a normal type of eruption. There are also places in the world where there are lakes of lava. Now, I wouldn't call these normal, but they're rare. There's about 6 to 8 at any given time in the world, and I've been to most of them. That's me at the bottom, standing next to this lake of lava. This is in Africa, in the Congo. And standing next to these things is extremely intense from the heat, all that liquid rock. I have to wear special suits to get close. Now, these are rare, but they're not weird. Today, we're talking about the weird stuff. We're diving in deep on super weird. And to find the weird volcanoes, we have to sort of know where volcanoes form on planet Earth. And most of them form where the tectonic plates, all of the land on Earth is basically kind of like rafts of rock that crash and bump up against each other. And these, we call them tectonic plates. And where these plates come together or spread apart or crash into each other or one dives underneath the other, that's where we end up with volcanoes. And all of those red dots on the map there represent where we see volcanic activity. So, as I mentioned to Jesse earlier, there's about 1,500 active volcanoes on Earth, and they don't have to be erupting to be considered active. They only have to have the potential to erupt. And at any given time, about 50 to 70 volcanoes erupt every single year. Some of them erupt every day. There are volcanoes that have been erupting every day for 2,000 years. But again, straight into the weird. And I apologize in advance. Some of these weird volcanoes also have really weird names. So I don't expect you to memorize these names, but I want to tell you the names of these wonderful places on planet Earth. So Kawa Ijen volcano, and I have been here. It is super weird. If you look at it, look at the colors. You've got these bright yellows on the left. You have this green lake in the middle of the crater. This is also in Indonesia. It's in the eastern part of the island of Java, sort of northwest of Australia. And there's the yellow color comes from the sulfur that is emitted by this volcano. It emits a lot of sulfur. And if you've ever smelled when someone strikes a match, that smell that you get, that is sulfur. And that's what this volcano smells like. If you go there, it's the gas, it's very overwhelming. We have to sometimes wear gas masks around these volcanoes. And in the picture, you can see a worker, they actually mine the sulfur from this volcano. So there are guys down there breaking off these pieces of sulfur, and they carry them up by hand. And I've carried one of these baskets. They are unbearably heavy, unbelievably heavy. And they'll walk for like 3 kilometers out of the volcano. And that sulfur is used for vulcanizing rubber. When you have rubber, to make, let's say, a tough tire out of it, you have to put it through this process called vulcanization. Volcano. Vulcanized rubber uses products from volcanoes to actually do its job. So that's pretty cool. And that sulfur oozes out of the side of the volcano as this liquid. And it's really hot. You don't want to touch it because you'll get burned. And it comes out this bright orange color, this deep orange. And then when it cools, it dries, it hardens, and turns yellow. And the yellow is what these miners are removing. But at night, it burns blue, this gorgeous blue, almost psychedelic, iridescent blue color. Now the lava, it's not really lava, it's liquid sulfur. I guess technically you might want to call it lava. But this liquid sulfur gives off a lot of these sulfuric gases. And some of those gases are flammable. And the heat from that liquid sulfur ignites the gases, and those gases burn blue. It's the only place in the world where you can see this phenomenon, this bright blue burning volcano. And to give you a sense of scale and the size here, there's some people on the right, there's a few people on the left. You can see the yellow sulfur. You can see some of those gases. And you can also see where those gases are burning with that blue flame, which is really cool. Now, we think of fire as typically being this orange or red color, right? Typically, most of the time. But different things, different chemicals burn with different colors. Like if you're burning like a copper sulfide, it'll burn green. So because of the gases burning here, it just so happens that those gases burn blue. And just to sort of make this kind of interesting, that's how fireworks work. Because or fireworks explode and they have all these different colors, these bright yellows and whites and reds and oranges. Well, there's different chemicals in the fireworks that burn and burn showing different colors. So this blue burning volcano is kind of like nature's fireworks. I kind of like to think of it like that. And the green lake, well, that's not just water. That is the world's largest lake of sulfuric acid. It is literally a lake of acid. And how strong is it? Well, we measure the strength of acid on something called the pH scale. And the further you go to the right into the blues and the purples, you get into the higher numbers, and that's less acidic. That's what we call alkaline. things like bleach. You don't want to be touching stuff that's too alkaline, but you also don't want to be touching stuff that's too acidic. So 7 right in the middle, that green 7 is just pure tap water. You can drink it, it's fine, your body loves it. But the further to the left you go, the more acidic and the stronger the acid is. So the acid that's in your stomach that you use to digest your sandwich that you had for lunch, it's about a 1 or a 2 on the pH scale. And the acid that's in a car battery is just below that. The acid at Kourounis volcano is 0.3. So it's about the same strength as battery acid. And how do I know this? Well, because I measured it. While I was at the volcano, I took a Coke can and I put it in the acid, and it started to sizzle like bacon frying on the oven, like on the stove, like crazy strong. And what I wanted to do is measure how strong the acid was in different parts of the lake. And the best way to do that is by boat. And so, yes, that is me in a small inflatable raft out on a lake of sulfuric acid, extremely strong sulfuric acid. And I had a special machine with me that I could use to measure how strong the acid was at different spots around the lake. I had a TV crew with me. We were filming for a TV program. And the lake itself is huge. It's about a kilometer across at its widest point. But the problem was, as I was paddling, the acid was dripping off of the paddle that I was using and was dripping into the boat. And so I started to get my pants started to get wet with sulfuric acid. And so I had to paddle like crazy to get back to shore, take out my knife, and I had to cut off my pant legs and turn them into shorts because they were soaked with acid. And then I had to pour water from my water bottle onto my legs because they were starting to burn. So this is definitely a lake that you do not want to go swimming in. I wouldn't recommend that at all. That's for sure. So that was Kourounis, one of the world's weirdest volcanoes. Mount Etna. This is in Italy. So it's actually on the island of Sicily in Italy. And if you think of Italy as a gigantic boot, like it's sort of shaped like a boot, right? And the island that boot is kicking, that's Sicily. And on that island is Mount Etna. It's the biggest active volcano in all of Europe. And it erupts very frequently. But every now and then, it does something super weird. It erupts and makes smoke rings. The first time I saw a photograph of this, it blew my mind. How can a mountain make a smoke ring? And it does it from time to time. Imagine you've got this cloud of gas. So notice the gas there, it's got a kind of a yellowish blue look to it. So that tells me this is more of that sulfur dioxide gas, the same kind that we saw at Egen volcano. And the volcano will sometimes have these, it sort of breathes out every now and then. It goes, whoosh, whoosh. And as it does that, it pushes gas up into the sky. And as that air moves the gas upwards, it forms this ring like a donut. And it continues to ascend up into the sky. The conditions have to be just right in order for this to happen. And it's one of the few places on Earth where this phenomenon has ever been observed. But they do occur in nature. These smoke rings, you can actually make your own vortex cannon out of a garbage can and some plastic sheeting and a smoke machine if you've got one, like a fog machine. It's actually a really cool science project to try at home or at school. Think about it. But they also are sometimes made with bubbles from things like dolphins and beluga whales. So they happen in nature all the time, but to see them happening at a volcano is super, super rare. And I've got a video here to show you of what it looks like when the volcano is making these smoke rings. I guess technically they're gas rings. So this was filmed by a friend of mine, my buddy Jeff. We've done a lot of volcano expeditions together. And there you can see the donut there, it's sort of spinning, and the gas is coming around the outside of the donut and getting pulled in an almost perfect circle. Really, really amazing. That's a sight you do not see every day. But wait, we're not even to the weirdest volcano yet. There's a place in Africa called Oldonyo Lengai. And it's a Swahili word. It means the mountain of God. And it's in Tanzania, in East Africa. And this is a really cool volcano. It's cool for a few reasons. Number one, you can go on safari and watch like zebras and other like giraffes and things like that while there's an active volcano behind you. But it is also literally the coolest volcano in the world because it has lava that is the lowest temperature of any lava. So the lava here is about 500 degrees Celsius, about 950 Fahrenheit. Regular lava, which we call basalt lava, is about 1,000 degrees Celsius. So this is about half the temperature of what I would call a normal volcano. But it's not just the temperature that's low, it's got really weird chemistry as well. The lava is made of some weird stuff. So it erupts frequently with a mineral that's called nitrocarbonatite. And this mineral, pardon me, is only erupted from this one volcano. There's no other volcano in the world that we know of that erupts this nitrocarbonatite lava. And because it has this mineral in it, the lava itself erupts black. It's not hot enough to glow bright orange during the day. So it looks like mud, but it's actually lava. And it flows very quickly. When it comes out fresh and hot, it's black. But when it cools and hardens, it turns white. So it's so weird. You can really tell where all the fresh lava flows are just by looking at the color. It's so easy to tell. And at night, it does glow a little bit because it is hot enough to, if it's dark enough and you've got a camera that does long exposures, you can sort of see a little bit of a glow. But the lava here is so weird. It's kind of like being on another planet. There's nothing alive up there. There's no plants or anything. And I've got a video here showing you just how this lava flows. Look how fast it flows. It flows like water. And it's so cool that the person in this video can actually scoop it with a kitchen spoon. If you were to try that with regular lava, your face would melt. You just couldn't possibly do it. So that gives you an idea of how weird the lava is at this particular volcano. It looks like oil or mud flowing. Really strange. Okay, I got two more things I want to share with you. Now, I'm sure you're wondering, why is there a photo of a storm on the screen right now? Well, lightning, we typically think of lightning happening during thunderstorms because that's where we usually see it, right? Where we live, where I live, where you live, if you're going to see lightning, it's usually in a thunderstorm. But that's not the only place where you can spot lightning. Some volcanoes create lightning in their eruptions as well. This is a volcano in Japan called Sakurajima. And when you think about it, lightning is nothing more than a discharge of static electricity. If you drag your feet across the carpet and touch a doorknob, that spark that's created, that zap, is static electricity. The same thing happens in thunderstorms and in volcanoes. In thunderstorms, you have ice crystals rubbing up against each other. In volcanoes, you have volcanic ash particles, billions and billions of them, these tiny little fragments of rock that are microscopically small. And as that cloud of ash goes up into the sky, these particles of ash rub up against each other and they create these gigantic sparks. And I've only been able to photograph it once in all of my volcano expeditions all around the world. This is it. This is at a place called Krakatoa Volcano. Technically, it's called Anak Krakatau. It's in Indonesia as well. And what's interesting is there was a volcano last year, in January of last year, a volcano in the South Pacific that had the most lightning ever seen. And it's got the worst name ever. I will not ask you to spell this one. It's pronounced Hunga Tonga Hunga Ha'apai. And it had a gigantic explosion, one of the biggest explosions we've seen in hundreds of years, I believe. It's right in the, it's certainly one of the biggest. And it had so much lightning in it. It had 2,600 lightning flashes per minute, and it erupted for hours and hours. Imagine being in a thunderstorm where you have 2,000 lightning flashes every minute. This is just absolutely insane. Scientists, their jaw hit the floor when they studied this volcano eruption. More lightning than any storm, more lightning than any volcano. This was the highest concentration of lightning that anyone has ever seen. And here's what it looked like from space. So we're looking down from a satellite, and you can see the explosion. That's all that volcanic ash going up high up into the atmosphere. And all that orange and yellow little pluses and minuses, each one of those represents a lightning strike. And this went over about 14 or 15 hours of this massive volcano eruption in Tonga. So yeah, pretty wild stuff. I can't imagine what that would have been like to see in person. You wouldn't want to be too close, though. That's for sure, because this explosion was massive. Now, there's one more thing I want to share with you. And most of us will never get to see these volcanoes. But about 80% of them, of the world's volcanoes, are underwater. And things get really weird down there. So, of course, about 70 to 71% of the Earth's surface is covered in water. So you would expect that a lot of our volcanoes are covered by the ocean. As a matter of fact, most of them are. And there's a phenomenon down there called deep sea hydrothermal vents, sometimes called black smokers. And these are underwater volcanoes, and they're really deep, down in the depths of the ocean where no light can get to. It's pitch black, the water is close to freezing, there's tremendous pressure, and yet there are these volcanoes down there. And in the middle of these ocean, there are these ridges where these tectonic plates that we talked about earlier, they spread apart. And the Earth's crust gets really thin there. And because the crust is thin, it makes it easier for volcanoes to form. And that's where these black smokers, these hydrothermal vents happen. And they happen in every ocean. They're all over the world. We just don't get to see them because they're in places that are very, very difficult for us to get to. I've never seen one in person yet, because you need some special submarines to get down there. So here's an example of a submarine. There's the arm of the submarine gathering some samples from this vent. And so it's ejecting all of this, this material. There's a lot of hydrogen sulfide gas that's in there. And what's really interesting is that, well, there's a few interesting things actually about these deep sea hydrothermal vents. Some of them are 8,000 feet deep, 2,500 meters, so really deep. We never even saw these things until 1976 for the first time. They were spotted for the very first time by oceanographer Bob Ballard, a very famous oceanographer. He's the guy that discovered the Titanic. And there's a really unique ecosystem of creatures that live only around these volcanic vents. We used to think that all life on Earth originated because of energy from the sun, right? The sun hits the Earth, the plants create photosynthesis. They use photosynthesis to create energy and then to grow, and then animals eat those plants and other animals eat those animals. Well, the creatures that live down here don't care about the sun. They get their energy from these volcanic vents through the chemicals. It's a process called chemosynthesis. Really interesting. So there are bacteria that create, that feed off of this volcanic chemicals that are in the water. And then there are other creatures that feed off of them and have symbiotic relationships. They work together. So there are giant tube worms that live down there. Some of these are 2 meters long, 6 feet long. They're huge. And they're only found right beside these volcanic vents, nowhere else on Earth. There are things called Yeti crabs. Look at that thing. How weird is that? It's a furry white crab that looks like it's wearing a fur coat. And these things will eat the bacteria that feed off of the volcanic chemicals. And there's even crazier stuff down there. Things like this octopus called Volcano octopus hydrothermalis. I just love that name. It's what's one of my favorite animal names. And it really tells you what's going on. Volcano, octopus, hydrothermalis, right? It's a volcanic octopus living at these hydrothermal vents. And this species, it's not found anywhere else. Super weird. It's almost like an alien planet down there, and it's all because of the volcanic activity. So I'm sure you got tons of questions. That was just a real sort of quick dip into the world of the strangest volcanoes on our planet. And I could just go on forever because there's so much weird stuff out there. I love it. The weirder, the better.
George, I mean, this is for you and for our classes. I've hosted 1,500 broadcasts for the last 8 years. I've hosted you like 35 times at this point. I always learn new things. I always see new things that I've never seen before. The whole first half of that was mind-blowing. So thank you so much for that. For many of our students, a lot of that whole thing will be new to them. And it's just, the world is a pretty special place. And I'm so glad we got the chance to hang out with you to share some of its more unique elements today. As you said, we're going to dive into questions really soon. I'm going to do a quick Kahoot quiz for our classes. This is stolen straight from our bigger Kahoot that you did in conjunction with Joe. So you can head to our Kahoot page and check this out. For those who are new to Kahoot, the faster you answer, the more points you get. And what you win is George and I's everlasting respect. Really is. And that George's everlasting respect is not easily given. So this is your moment. We're going to start off with this in just a sec, and then I'm going to head to YouTube for a few quick questions and then take some from all our live classes. Of course, we have got classes in Alaska, Iowa, Georgia, Nebraska. We are all over North America today. It's like the widest geographical range I think we've ever had, which is pretty exciting. So
that's awesome.
I'm going to get started with this. Let's dive in. If you're on YouTube especially, try and get your answers in extra fast. Sometimes it's a little glitchy for people on YouTube, so I hope it goes well for you. Here we go.
All right, let's see if I can answer some of these.
I think you got these. Most of the world's volcanoes are. I mean, you just talked about this. Are they erupting, undiscovered, underwater, or in Australia? Scary land of kangaroos and volcanoes, maybe.
All right, so that should be an easy one.
Yep.
I expect to see a lot of right answers here.
I think so too. I really, yeah. 6 more seconds. Over 100. Biggest Kahoot of the year so far. Way to go. Holy, and they keep rising. The answer. Nice. 80%, yes. Most of you got this right. Underwater is correct.
Good job.
I hope you get to go to one underwater. That, like, being in one of those submersibles is one of the great joys in the world, I think. So,
yes, absolutely. I would love that tremendously.
All right, question 2. Volcanic eruptions can create new islands. We actually definitively, you know what? I can't say that. Never mind. It's too much of a hint. 68 is it far? What do we think? I mean, our American
can create a new island.
Our American friends, I mean, you might have a state that fits the bill here, like an entire part of the country. The answer is, of course, true. Anak Krakatau is an example of this, where
I have actually the Hungatonga Hunga Ha'apai volcano. When I visited it in 2009, it had just erupted out of the sea and created a new volcano, and I was one of the first people to set foot on it.
Of course, you were. You and the spiders, they tend to be the first thing to land anywhere that there's a new island. And then George shows up right after. All right, sound from the Hungatonga Hunga Ha'apai.
We're just talking about this volcano. I didn't mention this specifically, but I did mention that it was pretty big, didn't I?
Big, 9,000 kilometers away. So if you know geography, you don't even need to know exactly where. Just not what's 9,000 kilometers away. It's just a sense of the outlandishness of the sound. Is it Indonesia, Australia, China, or Alaska? And the answer is Alaska, actually. Indonesia, it's right there. It's right beside Indonesia. They definitely heard it there. But Alaska's on the other side of the world. We're going from way south to way north, and you can still hear this eruption, which is absurd.
It's so hard to believe that that was true that it doesn't even seem physically possible. So I'm not surprised that not everyone got that one, because I barely believe it myself, and I know it's true.
We really screwed up the leaderboard there. Amy Raven just took a lead out of the blue, going to our final question, and then I'm going to head to our YouTubers for queries after this. Volcanoes form when tectonic plates. This is straight from our larger Kahoot. Collide, move apart, stop moving, or get stuck on each other. I will note that some of these create earthquakes, which are interesting quasi-related phenomena on the edge of tectonic plates. But our main answer here is, as 160 of you are soon to find out, collide. And most of you got that right. So way to go. Let's check out our
See, I will point out
Yes.
Some of them do form these undersea volcanoes.
I know.
And the plates spread apart. So
this is my thing. I'm making the Kahoot, and it's set up that way with Joe, and I'm like, wait a second. I'm pretty sure. Anyway, so good.
I'm gonna.
We will. You know what? It's under dispute. Protest for the Kahoot. That's okay. That's fun.
Yes,
absolutely.
Although most of the ones that we see do form when the plates collide together. That I'll give you that.
Okay, but one of the ways we know plate tectonics is real is the plate spreading in the middle of the ocean, which is wild to think about.
Africa is literally splitting apart because the Great African Rift Valley is one of those rare spots where we can see on land, we can see plates moving away from each other.
Is this true in Iceland too? Yes?
Yes.
Yes. Okay. George, this is spectacular. We've got at least 15 minutes for questions. We've got a bunch of great live classes. I'm going to shamelessly head to my junior school, Broad Acres, where I was a boy at grade 1 through 5. They're here today, which is really exciting. And their question is, why didn't the dinghy melt in the sulfuric acid lake? Which actually, I had the exact same question. So
that's a great question, right? How did I know that the rubber boat that I was in was not going to melt underneath me? And that would have been an awful, awful thing if it had. But think about it this way. If you're a scientist working in a lab and you have to move some beakers of acid around, what do you wear on your hands? Rubber gloves.
Yep. Did we freeze? We froze with George. The acid lake didn't want you to know that.
Yeah, there we go.
There we go. You're back.
Yeah, I'm back. Excellent. So by having a boat made of rubber, similar to rubber gloves when you're working with acid in a lab, the acid does not affect the rubber. I was concerned about maybe some of the seams, the seals, if they were glued together, it might dissolve the glue. I was also worried about the aluminum on the paddle because I knew from the Coke can that I put into the acid that it does start to dissolve aluminum. So I did a bunch of tests. I put the boat in and I tested it, and I didn't just jump in and go, right? I try to do these things very methodically and safely. So I knew it was relatively safe.
I'm glad we got that point. And I mean, I'm going to go to lots of questions. We might get a variation of this in the future, but George does prepare. Every explorer that we have on, whether it's polar, cave diving, volcanology, like you don't go in willy-nilly. A lot of prep goes into these expeditions to make sure that people are at the lowest possible risk of injury. And you've been remarkably lucky with injuries, as I will leave a kid to ask, because I'm sure we will get that question very, very soon. Ms. Bullock, I'm coming to you guys in Katala in just a minute. I want to take one from our folk at Longfellow Elementary, Mr. Backus's class. Adrian wants to know, so I was totally wrong. How many volcanoes have you been to? No pressure.
I've got a map of the world above my desk, and I'm gonna guess at least 30.
That's pretty solid.
Probably more.
Yeah.
And those are the ones I'm counting that are actually active, that are doing something. They're either erupting lava or ash or sulfur or something.
Cool. Well,
there's a lot more if you consider the quiet ones.
Thanks, Adrian, for the question. Classes, I know a lot of you are at the camera. I am coming to all of you, I promise. Miss Bullock's class, come on in Georgia first. And hey!
When's your next volcano expedition?
When's my next volcano expedition? I'm not sure. I don't know yet. I'm working on that right now.
Yes. All right.
I'm not sure.
To be decided. Do you have another expedition of any kind planned in the not too distant future? What's next?
Well, right now it's hurricane season.
Yes.
And so I'm keeping an eye on that because I chase storms as well. And then later on this year, I'm going to be going back to Antarctica.
Ooh, lucky you. We were just talking to Hugh Griffiths today, Antarctic biologist. So if people want to find out, that's on our channel as well.
Nice.
We are going to head to Gambles, Maryland, School of the Incarnation. Ms. Rahim's class, welcome back. So nice to have you guys, and take us away.
Hi, guys. Thank you. Go ahead, Haley.
What was one of the most dangerous volcanoes you've ever been to?
Ooh. Ha. I've got two examples. One of them was Fogo Volcano in the Cape Verde Islands. It's a series of small islands off the west coast of Africa. And I was there, and the Fogo Volcano
Oh, froze again. He'll be back. Just a second. While we're waiting for him to be back. Oh, there you go. You're good. You're back.
Okay, good.
Sorry for the trouble.
Okay, it must be at my end. My technical difficulties are continuing, but not too bad. So this Fogo volcano in Cape Verde Islands was producing this lava flow that was slowly working its way into the local village. And I was inside one of the buildings filming, and I was talking to the camera, and I could hear the pieces of lava hitting the door beside me. And then very quickly, the door burst open, and all of these chunks of lava, hot lava rock, came tumbling into the room with me. And then less than a minute later, the entire wall collapsed. So I got out of there pretty quickly. And there was another instance. I was in Vanuatu, which is a small country in the South Pacific. I was at Yasser volcano, and it erupts every day. And there were come on.
It wants to work. It's thinking about it. It's
There we
go. Vanuatu, it's erupting every day.
Yes. So this volcano erupts every day, and there were pieces of lava flying hundreds of feet through the air, and they were landing behind me.
Fantastic. So, okay. Well, I knew we were going to get that question. Fantastic, guys. Fingers crossed in tech stuff. We're going to go to Mr. Tim's class, our 7th graders, LDNE. Come on in. Welcome in.
Did the volcano underwater used to be on land and then just sunk in the water, or were they already there?
Cool.
It's kind of the opposite, actually. So what happens is they start off underwater. So think of it this way: you've got these two plates, these tectonic plates, and they're moving apart. And the volcano, you got that heat from deep in the earth coming up, and it's pushing. These plates are spreading apart, and the volcanoes form there. And then later on, these plates, these thick pieces of crust, become the continents that you and I are standing on right now: North America, Europe, Africa. So it kind of goes in the opposite direction. It's not so much that there's a volcano that sinks into the water. It's a volcano that's in the water that creates the land that you and I are standing on. But it takes millions of years.
I love that question. Thanks, guys. By the way, so nice to have a Nebraska class. I think it might be the first time we've ever had a Nebraska class, so way to go. Miss H's class, I'm heading to you guys. Unmute your mic. Miss T, you're next, and I'm going to take as many from YouTube and try and do another round as I possibly can, everybody. Hey, guys.
Hi. My question was, have you ever studied the eruption of Pompeii or been to that eruption site?
Yes, I have. So Pompeii is the ancient Roman city right near the modern day city of Naples or Napoli in Italy. And very close by is the Vesuvius volcano, hard to pronounce sometimes. And back in 49 AD, it had a big eruption, and all of this volcanic ash completely covered the city of Pompeii and smothered it. And for thousands of years, it remained buried. And then archaeologists were able to discover it, very well preserved. And I've been there, and it's amazing. If you ever find yourself in Italy, it's like stepping back in time, going to an ancient Roman city. It's so well preserved because it was coated in all this volcanic ash for so long.
We may need to talk about this, George, but I've been trying to reach out to the archaeology team there because that would be an amazing thing to do a live broadcast from, and they're unresponsive to emails.
And they're still digging there now. It's
unbelievable
process.
It might be the coolest archaeological site in the world. Like, it's so unique.
I loved it there. It was amazing.
Yeah. Miss T's class, we're going to head to BC. I'm going to take a couple from YouTube and try and do another round. You guys are amazing classes. Welcome in, grade 3s. Hey.
My name is Joshua, and what inspired you to look at volcanoes?
Thanks, Joshua. Nice to meet you, and I appreciate the question. So when I was young, I was always interested in science and nature, and I originally kind of wanted to be a marine biologist. But then as I grew up, I got more interested in getting into photography and exploration, and specifically extreme weather. And so I started chasing tornadoes, and then I started going to document wildfires and hurricanes, and then volcanoes and avalanches and icebergs and climate change and all these different things. So it started off small with an interest when I was a kid, and it just kept growing. And now I have the wonderful opportunities to travel all over the world to showcase some of the most amazing places.
Great question. Thanks, man. All right. I'm going to head back to Ms. Bullock's class. We're going to do another round with everyone. Thank you so much for all this, George. Come on back in, Georgia. Take us away.
What would be what are your thoughts on what would happen if Yellowstone exploded and how would it affect the U.S.?
Right. So Yellowstone, it's in the central part of the U.S. in Wyoming. Most of it's in Wyoming, and it's not just a volcano; it's a super volcano. So super volcanoes are capable of having absolutely massive explosions that can have worldwide global effects. So there's been a history throughout the history of the Earth. There's been a number of these super eruptions. There's at least half a dozen that I know off the top of my head of these super eruptions that have happened. And Yellowstone has had numerous eruptions over the years. But it's unlikely to happen because, I mean, it could happen technically, but the part of North America, the crust of North America, as it's moving over top of where the Yellowstone volcano is, the crust is getting thicker. So the lid on that volcano is getting harder. It's getting thicker. So the odds of it exploding are not very high. But let's say it does.
We'll have to find out in a sec. It's not the best. Oh, in fact, you're right at the point where you're like, let's say it does, and then you
let's say it does erupt.
Perfect moment for that. Thank you.
If it did, it would throw volcanic ash almost up into space, and that ash would come down, covering much of the eastern part of the United States. That ash would stay in the atmosphere. It would circle the globe. It would drop global temperatures, which you think might be a good thing, but it's not really in this case, because it would cause widespread crop failure, which could be disastrous for a lot of people. So yeah, it would be a real bad thing if that were to happen. It likely would not cause the human race to go extinct. We would survive, but it would suck for a very long time.
That's an understatement. And a question that we got on YouTube as well. So I'm really glad someone brought up Yellowstone. Thanks, Ms. Blokes class. Ms. Rahim, I'm heading to you. I'll take one from YouTube. And then Nebraska and Ms. H, I'm coming right back to you guys in just a second, but come on back in. Hey.
Hi, I'm Abigail Ritter, and I'm in 6th grade. My question is, what is the hottest volcano you've ever been to? You said the coldest, but...
Oh, Abigail, I think you stumped me. I don't know what the hottest one is. The reason why I know what the coldest one is because it's... Come on, computer.
Yeah, it's back. We're good.
Yeah. Imagine how hot all the volcanoes are, and then the coldest one is way down here. It's so much colder than all the others. So I don't know off the top of my head which volcano is the hottest. So now you've piqued my curiosity, and I have to go do some research.
We'll have to do a second broadcast just to have George back for this. Mr. Tim, come on back in and take us away. Unmute your mic, and you're all good to go. Science.
What education did you go through to be able to study volcanoes?
I love this question, especially with George's answer, which is so unique from everyone we have on. So awesome question, man.
Great question. I personally am not a volcanologist. I specialize in documenting all of these different forces of nature. So I deal with weather, I deal with geology, meteorology, volcanology, all of these different disciplines. So I'm an engineer by study. I used to build recording studios and such. That was my education. And then when I got older and got passionate and really interested in documenting all these things, I taught myself through a lot of reading, a lot of mentoring, a lot of studying, working with other experts, was able to learn about all these different disciplines. There is no school to go to that teaches all the things that I do. There we go. So basically, because what I do is so unique, I've had to sort of learn on the fly, by the seat of my pants, if you will.
Thank you for the plug. Miss H's class, we're going to head to you guys for one last question. Welcome in Ontario. Unmute your mic, and you're good to go. Hey, guys.
All right. That's Serena.
Hi. My question was, is the smoke ring in one of the eruptions like a tornado, where the hot air mixes with the cold air and can become a tornado?
Interesting.
Yes and no.
Okay.
So that air that's coming out of the volcano is hot. the gas and the air, it's warm, right? So that heat wants to rise, very similar to what happens in a tornado. But it doesn't spin this way. With the tornado, you have to have something called wind shear. And that's where you have wind coming from different directions at different layers in the atmosphere. And as that warm air rises up through those changes in wind speed, it causes it to rotate and spin. But here, the rotation isn't happening like this. The rotation is happening like this. So it's kind of similar in that, yes, you've got rising hot air, you've got rotation, but that rotation is happening in what we'll call in a different direction, a different axis, if you will.
I like it. Classes, this is one of the most enthusiastic Q&As I've ever had, not just this year. Like, you guys are an amazing audience, so thank you so much for that. I'm going to email all your teachers with more resources about George. You can keep following the work that he does, all those up-to-date expeditions. See the next time he heads to a volcano. I'm sure it'll be on the bottom of the ocean soon enough. We'll give it like a year or so. Check it out on YouTube. Share with your friends and family. George, is there any last message you want to share before I bring in the classes to say thank you and farewell? And then you want to leave us with today about volcanoes?
I just want to thank everyone for coming out. And I find volcanoes fascinating because they may be a destructive force, but they're also a force for creation. They create most of the land that we live on. So we sometimes have to be afraid of them, but we also have to appreciate everything that they provide for us.
Couldn't be a better message than that. Teachers on YouTube, send me your questions. I'll try and answer as many as we possibly can. I know we couldn't get to them all today, but in the meantime, Miss Bullock's class, Mr. Tim's class, Miss H's class, Mr. Rahim's group, thank you so much, everybody. Have a wonderful day.